Hi, my name is Nicholas Vu, and I currently am an undergrad student at Texas Tech University. And I currently research in the kinesiology department under Dr. John Harry with the assistance and guidance of Daniel Schroer. So, post-activation potentiation involves the change in force time and force velocity that will lead to an increase in power output. This is shown in vertical jumps used by athletes in volleyball and basketball when doing barbell resistance training. This effect would increase the amount of force and height produced during a tested jump immediately after the resistance exercise. And so, taking that idea, what remains unclear is whether or not if the same thing could be applied to horizontal jumps with a weighted vest instead of a barbell. So the purpose of this experiment or research is to determine whether utilizing a weighted vest will induce post-activation potentiation during horizontal jumps to improve performance by way of increased horizontal displacement. This study seeks to identify a new strategy to supplement contemporary training protocols employed immediately before a horizontal jump test. Given the body of related work on post-activation potentiation, we hypothesize that potentiation effects will occur and to increase horizontal jump displacement. So the methods that we'll be using throughout this experiment would be the gathering and using of 30 participants with previous strength trainings and jump experience with at least 2 years, and they will be asked to complete one laboratory session. Participants will be asked to perform several standing long jump repetitions with and without a weighted vest with 10% of their body weight. 3D motion capture force platforms and muscle activation instruments will be utilized to obtain measures of horizontal displacement, internal and external force application, and neuromuscular volition. And so the way we are conducting the experiment is basically separating each participant into different categories, and these categories would be odd numbers and even numbers. And depending on the type of number that they are, they would proceed with the procedures listed in the picture shown here. And so, for example, a person that is an odd number would proceed with the odd number procedures, and after they are done, they would proceed to the even number procedures. So going on to the methods that we will be using to collect the data, we will be using sensor markers. And these sensor markers will be placed onto certain landmarks of a person's body, and they will be picked up by a series or multiple cameras around the lab that we have within an area. And they would form a computerized model of the participant. We would also use EMGs, which basically will be attached to certain muscles of a participant, and they pick up on the activation of the muscle that they are attached on. So on the bottom left, we have an example of an EMG on the rectus femoris, and the EMG picking up on the signals of the muscle produced, as you can see from the graph. And so here we have the image of an example of how these sensor markers work, and basically how they are picked up within the cameras and computerized to make a model of the participant. And so going on to the results and discussion, the data collection and analysis is still ongoing. However, the data appears to be in favor of supporting the hypothesis, and we anticipate statistically significant results through the continuation of the project. We anticipate that the results will continue along the current trend, and potential effects will be shown to increase horizontal displacement by way of increased force application and neuromuscular volition. And here is my reference sheet, and this concludes my presentation.